Hi Dr. Dempsey, thanks so much for joining us. Today we'll be asking some questions to better understand the courses you teach in the new student-directed research project you're developing for fourth-year honors specialization students that they can take in place of a thesis project. Could you tell us a little about yourself?
Sure. Well, I'm excited about biochemistry. I love biochemistry, and that's one of the reasons that I'm here. I've always been interested in biochemistry, so I did an undergraduate degree at McMaster University in Hamilton, and then made the transition to graduate school, and I came here to London as a graduate student. I met my wife as a graduate student, so grad school is definitely a good place for everyone to be and do great research and move on with their lives. After that, I did a postdoc at Agriculture Canada, and then I came back here and did more research as a research associate, and then I became really interested in teaching. And so I went out west to the University of Lethbridge and did a lot of teaching intensive things there, and that's where I kind of became very interested in synthetic biology and team projects and things like that, and I brought that interest back here, which is part of the project course that I'm trying to develop now for fourth-year students.
Great, thank you. So what courses do you teach?
Well, I teach a variety of courses here. For a while I've been teaching and associated with the Biochemistry 280 course, which is the second-year introduction to biochemistry. So I really enjoy that course because it's kind of the first chance that students get to see biochemistry and understand biochemistry. But I've also been teaching a third-year course, Biochemical Regulation, which is also known as 3382, as we always call them by their course numbers. And I teach that course as part of a team as well. I've taught various other fourth-year courses and grad courses, but a little less regularly.
And if there's one thing you could tell students looking to excel in your classes, what would you say?
Attend lecture. I know that's not popular, but that is, I think, setting aside that time, that 3 times a week or whatever the course design is, showing up to lecture and focusing on the material at the minimum in those hours every week, and making sure that's the time that you're focusing on the content and thinking about the content and understanding the content. That's the best thing you can do for your learning and to excel in any course is do that. Spend some time, and since that's dedicated time already, we know what fits in your schedule, that's a good time to really get the content and get the material and do well.
And could you briefly tell us about the research you conducted?
So I don't currently have a research lab here at the university, but I've had a fairly long research career through both grad school and my various postdoctoral positions. So as a grad student, I worked with Dr. Brian Shilton, who's still here in the department, and I looked at structural and functional aspects of how bacteria get proteins that they make from inside in the cytoplasm to the outside. And they do that using this specialized motor protein, and so we worked on trying to understand how that protein functioned. At Agriculture Canada, I worked on methods to make plants produce therapeutic proteins. So the concept being that you could make a plant produce large amounts of something like an interleukin to reduce inflammation of the GI tract. And if you can make the plant produce lots of that protein, then they could potentially consume, a patient could potentially consume that protein and see all kinds of health benefits. And then I worked on various aspects of brain signaling and dopamine function and calcium interactions when I came back here to work with Dr. Shaw as a research associate.
Great, and the next question is, what is your favorite part about teaching?
It's interacting with students. To be honest, that's the most satisfying part of teaching for sure, is posing a question to the class and having the opportunity to see kind of the wheels turning and students thinking about how to apply the material to the situation that you've kind of proposed to them. That's the most fun part of teaching, is getting to interact with the students like that. And then in reverse, having students come to you with one of those kind of like really good kind of like questions where you can see that they've thought about the material, and maybe they're struggling with it, but they're still at least trying to think through it and use the information that they have, and that's just that's absolutely the best part. others, just kind of sharing that learning together.
So regarding the new course, could you give us a brief overview of the new course?
So the objective that we have in the revision of the Bachelor of Medical Sciences is to ensure students have a lot of options and variety in their culminating experience. In their final year, we want them to have more choice, so they can choose to do an honors thesis and research like that. But if they're more interested in directing things into, for example, the course I'm developing, which is kind of working as a group and really helping prepare themselves for their after graduation experience, then that's what we're kind of trying to put together. The course in general, the point is to provide students with a group project where they can work on the lab, develop a project of their own, and really think about the content and how they would direct research.
What skills and experiences should students expect to develop from this course?
So the point of this course is to give students the opportunity to develop the skills that they want. So as part of a group project, they'll be able to choose the topic, and that topic will allow them to explore all kinds of interdisciplinary aspects of research. So if they're interested in computational methods or modeling, then they could handle that side of that project, while another student that's more interested in, say, wet lab research could take over that aspect of the project. And the whole team will have to work together as far as designing and developing the concept of the project. And then there'll be mentors such as myself and other faculty members to kind of help direct those research efforts. So students won't be on their own for sure, they'll still get to work with faculty. But really we want them to be able to say, I want to know more about this skill. And then we'll provide them with that opportunity.
How would you say that this course is different from a typical thesis project?
So typically in a thesis project, students are going to have to find a supervisor who works on something that interests them, but it's kind of a matchmaking system. And the students will be kind of held to a project that's been designed by that supervisor, and that's a great model. That's a great way to learn in the wet lab or computational modeling, depending on what supervisor you're working with. But the goal of this fourth year project course is to allow students a little more freedom so that they can kind of tailor their learning experience to get them ready for graduation and the next step after that. And that's really a great opportunity, a chance for students to sit down and say, I'm really interested in, say, computational modeling methods, something like that. And then they can, help work on that aspect of the group project, because we can certainly incorporate all kinds of different methods and techniques. And the projects are really supposed to be interdisciplinary. So the point is to allow students to work on ideas and concepts they want that they can then put on their resume and go out and shop to companies or to grad schools or to any other place that they want to be.
What are the pieces of equipment used?
So students working on the fourth year project course will have an opportunity to work in the biochemistry department's BioCore facility, which houses a whole suite of equipment for production of proteins and analytical molecules, their purification, and as well as their analysis and studying. So the instruments we have are for protein and cell growth, protein and cell purification, so systems like column purification and pumps for that type of thing, centrifuges for purification of either proteins or cells. And then on the analytical side, so those first sets of equipment were really about the production process. We have analytical methods for looking at protein-protein interactions in high throughput, imaging systems for detecting fluorescence or other types of molecular interactions, isothermal titration calorimetry and various methods like that, fluorimeters, circular dichroism, and even methods for synthesizing nucleic acids in a high throughput manner. So we've got all kinds of equipment, and students can really learn how to use these really modern instruments in working in the course.
Great, thank you. So my final questions are, what is your favorite coffee and what is the best food spot on campus?
So my favorite coffee is anything I bring from home, and I kind of change up whatever beans I buy, but I guess I like the Kicking Horse coffee, and Muskoka Roastery's got some good stuff too. So.
And what is the best food spot on campus?
It's got to be the grad club. I mean, I was a grad student here, so I went to the grad club a fair bit. They've got some beers on tap, and they've got good food in the kitchen, so yeah.
Thank you so much, Dr. Dempsey, for your time and your invaluable insight.